This is 2-4 inequalities with variables on both sides. Again, same rules as solving equations. Keep in mind, if we are multiplying or dividing by a negative on both sides, we need to flip the inequality sign. Also, before we graph, we want the variable to be on the left-hand side. So let's take a look at the first two examples. In order to eliminate the fraction, I'm going to multiply, for example, I'm going to multiply both sides by -2. So I'm multiplying both sides by a negative already, so I'm going to reverse this inequality sign. X plus 5 instead of greater than is going to be less than -6. Then I can subtract 5 from both sides and to isolate x, and x is less than -11. Okay, so if I put -11 on the number line, and next to it I could have -12, and to the right I would have -10, and it's an open circle, and it's going to the left because it's less than. As set builder notation, all values of x such that x is less than -11. Okay, next, if I'm isolating t in this case, I'll just block that off for a minute. To get rid of the -8, I would add 8 to both sides because -8 and 8 is 0. That's what we wanted. So we end up with -2t is greater than or equal to +2. Now I'm multiplying or dividing. So if this is multiplication, I'm going to divide both sides by a negative. Again, I divided both sides by a negative, so that's a reverse of the inequality sign. Flip the inequality sign to less than or equal to. 2 divided by -2 is -1. So we could put -1 on the number line, 2 spaces away, or 1 space, however you want to think about it. I'm just going to put it over here. -2, and to the right would be 0. And it's a closed circle because of the equal to sign. It's less than, so it's going to be to the left. And as a set builder notation, all values of t such that t is less than or equal to -1. Okay, for example 2. We have to simplify this first. On the left-hand side, there's a lot going on here, so I can distribute 2p minus 6, -3 times 2p is -6p, -3 times 6 is -18. Careful those negatives. It's greater than 4p. Combine like terms, so the p's can combine on the left-hand side. I'm not doing opposite signs because I'm on the same side right now. 2p and -6p makes -4p. And then -6 and -18 is -24. It is greater than 4p. Okay, now I want the variables to be on the same side. I'm going to move the variable to the left in this one just so you can see something. So if I'm moving the 4p and I do the opposite, -4p to both sides, I still have something, even though there's nothing on the right-hand side. A lot of you have been making this mistake. That's why I did it this way. I want you to know that there's a 0 here. I also brought the p to the left-hand side because when we're graphing inequalities, we need the variable on the left. So I could have moved it to the right, but then I would have to flip when I was done. So -24. So now I just go about as normal. So there's my variable. To get rid of the -24, I'd add 24 to both sides. And -8p is greater than 24. To isolate p now, it's being multiplied by -8, so divide both sides by a negative. That's where we're going to have to flip that inequality sign. So instead of greater than, it's now less than. 24 divided by 8 is -3. So -3 on the number line, -4 to the left, -2 to the right, open circle. It's less than, so it's the left. And as a set builder notation, all values of p such that p is less than -3. Okay, example B. We're going to simplify again. So I'm distributing 2 times x is 2x. Plus 2 times 6 is 6 is less than or equal to, distribute the 1/2. Half of 4x is 2x, and half of 2 is 1. Combine like terms, 2x plus 6 is less than or equal to 2x. Well, 1 minus 1 is 0. So I don't even need that plus 0 or whatever you want to write. You don't need the plus 0. Get the variables to the same side. I'm going to do the same thing as before. I'm going to move the 2x to the left. So then I end up 2x minus 2x is 0. The variable is gone on both sides. So now I have 6 is less than or equal to, there's still something over there. We didn't lose the inequality sign, so it's going to be 0 because there's really nothing. 6 is less than or equal to 0. Is this true? Is 6 less than or equal to 0? The variable's gone now. This is like those questions we had before, all real numbers or no solution. where if it's true, it's all real numbers, and if it's false, it's going to be no solution. So 6 less than 0. Well, 6 is not less than 0. That's not true. So this answer is no solution. Okay, for example, C. Here's my variable. I need to add 1/4 to both sides. When I do that, I get 7/8 is less than 3/8 x. Now to get rid of 3/8, since it's multiplication, I'm going to divide both sides by 3/8. I'm going to do this on the side, but your calculator will do this for you. It's times the reciprocal, cross simplify, and I get 7/3. So 7/3 is less than x. Well, I didn't multiply or divide anywhere, so I didn't have to flip because of that, but I need my variable to be on the left. So this is going to change to x. Instead of less than, it's going to be greater than 7/3. When I need to move the variable to the other side, I have to flip the inequality sign. So to graph x is greater than 7/3, I'll just put it on the number line. 7/3 less than 7/3 would be 6/3. Greater than 7/3 could be 8/3. It's kind of cheating, but it works. So x is greater than 7/3. So open circle at 7/3. It's greater than to the right. So for all values of x such that x is greater than 7/3. Okay, and again, let's distribute. 12y plus 48 minus 3y is greater than 9y. I'm distributing again, plus 36. 12y minus 3y is 9y. Plus 48 is greater than 9y plus 36. When I move the variable to the other side, by doing the opposite sign, the variable disappears and I get 48 is greater than 36. Well, that's true. So for every single number out there, doesn't matter what the number is, it's going to work, because 48 is greater than 36. So this answer is all real numbers. Infinitely many solutions is another way to say that. Infinitely many solutions. Okay, the word problem. The average of Jim's 2 test scores must be at least 90 to make an A in the class. Jim got a 95 on his first test, plus the other test that he has to take. When you find average, you add them and you divide by how many there are. So divide by 2. And he needs it to be at least, he needs the average to be at least 90. At least, greater than or equal to 90. What scores can Jim get on his second test to make an A in the class? So this X represents our second test. Okay, so now we can solve. So we can multiply both sides by 2. 95 plus X is greater than or equal to, 90 times 2 is 180. Subtract 95 from both sides, and X is greater than or equal to 85. X is greater than or equal to 85.